Question 15. So let's put on information that we know. We know that point there is 4, 15. So we know that's 4. We know that there, that length of that line is 15. Right, we need to know the equation of this line. So how are we going to get the equation of this line? Well, we need to do it from the gradient here at 4. So in order to do that, we need to differentiate this part down here. So if we differentiate this, dy over dx, that's going to be 15 over 2x to the half take away 9. Right, we need to sub 4 into this, so that would give me 15 take away 9, which equals 6. Gradient of this line must be 6. So if we know the gradient of this line is 6, what I'm really interested in, I would like to know these 2 points down here. Right? They're really important. So this is when we're going to equal 0. So let's try and have a little think about the intercept. So let's put these points in. So we've got y is 15. All I'm thinking about is y equals mx plus c. So I've got the 15. I know the gradient is 6. I know the x-ordinate is 4. And then I've got plus c. So that's 24. So c must be minus 9. So therefore this figure there, that must be minus 9 there. Now I'm going to work out this one. And this is basically when y is equal to 0. So I'm just going to sub that y equals 0. So that gives me 0 equals 6x minus 9. Add 9 to both sides and we get x equals 3 over 2. All right, so we've got these key points. We've got this point, and this point up here. Now, what we're going to need to do is now we're going to split this up. So we're going to integrate this from 0 to 4. So let's write this down here. We've got 0 and 4. And what's our function here? This bit here. So 5x to the 3 over 2 minus 9x plus 11. Right, so we're going to do that in a second. And then we need to take away this triangle, okay, the area of this triangle here. So the distance from here to here is 2.5, so that's 5 over 2. The distance there is 15. We've got a nice right angle triangle there. So if we work out the area of that triangle, a half times this times this, so that bit there is 75 over 4. So we're going to do this part, and then we're going to take away 75 over 4, and then we're going to add that little triangle in there. And that little triangle is, if I just quickly sketch it, we've got 9, and then it's got a length of 3 over 2, right angle again. A half multiplied by this, so that gives me 27 over 4. So the answer is going to be this, take away this, add this. Now it is possible just to add, just to pop that into your calculator. If you're like me, don't like using my calculator too much, but let's just quickly do it just to make sure. It's good practice making sure that you can actually do the integration. So we got 5x, so we raise it by 1 and then divide by the 5 over 2, take away 9x squared over 2, add 11x, obviously tidy that up there. Alright, so that's just going to be 2x, 5, 2, take away 9x squared over 2 plus 11x, put in our limits. Now the question's a little bit nicer for us because one of the limits is 0, okay? It's obviously a bit of a pain when it's not. So basically we just need to sub 4 into this just here. And if we sub 4 into this, it gives us an answer there of 36. I think it's 64, take away 72, add 44, so that equals 36. So the overall answer would be 36, so that's the area of all of this. Take away this part, so that's not part of the shaded region, and then also add that little bit down there. which is, I've forgotten what it was now, 27 over 4. 27 over 4. And if you just pop that into your calculator, the answer is 24, which is, hooray, what we were looking for. So 24 units squared.